Okay, good day. Today's discussion is on chapter 13 on cognitive functions. So this will be a rather short lecture. Won't be going into extensive discussion with the entire material from the text, but the highlighted points I'll go over with you. So cognition, when we speak of cognitive abilities, you're thinking about how people acquire knowledge. How do you obtain information? So that's cognition. So cognitive pertains to how this brain we have in our skulls are absorbing information in our environment. So beyond saying cognitive, the chapter is also dealing with lateralization. Lateral, that is like moving side to side. Hemispheric specialization. Hemispheres. We have one brain with two hemispheres. So each hemisphere has a role to play in behavior. You have a brain, left side of the brain, the right side of the brain, left hemisphere, right hemisphere. They're specialized to do certain things. So in the chapter on cognitive functions, we'll briefly discuss some points to highlight just for this discussion. So left brain thinking is usually associated with linear thinking, mathematics, reasoning, language. So left hemisphere. Right hemisphere is usually associated with creativity, spatial skills, emotions, artistic abilities. So basically the right hemisphere is more holistic, left hemisphere is more linear in its thought process. Mathematics, reasoning, art, skills, emotions. So hemispheric specialization. So that's what that word lateralization means. Depending upon which side of the brain you're referring to, you're talking about it can have a different or a specific role to play. So the division of labor is different between the left and the right hemisphere. That's all we're talking about with this slide. So there's a left and a right hemisphere, and they must communicate somehow. There's a little white area right here. That white area is actually the corpus callosum. Corpus callosum. That's the part in the brain that allows the left and right hemispheres to communicate. So if that's disrupted in any way, there's going to be a problem with the way the left and right brain communicate with one another. So the corpus callosum is the large area. However, there is a point there in the front, anterior commissure, a point in the back called the posterior commissure. It's just making reference to places where the information is going from what left to right side of the brain. Anterior commissure, posterior or hippocampal commissure, and again the corpus callosum. So for most people in the left side of the brain, language is associated with their brains. So language, left hemisphere. And that's what we'll probably mostly emphasize for this quick lecture on cognitive function. So if you view the corpus callosum from the side, a sagittal section, that purple area right there, and if you look at it from above, all these striations or these connections between the two hemispheres, that's how left and right are staying in contact. It's not as though you only have one hemisphere you're speaking with, or one hemisphere is your only focus. But in the society we're living in, Western culture, it's mostly focused on standardized testing, linear thinking. Therefore, left brain thinking is emphasized. In other cultures where there may be more of a spiritual nature of how they deal with the world, not trying to control and dominate things, the right hemisphere functioning may be more emphasized. But it's not as though you don't use both sides of your brain. It's a matter of which is more emphasized, and more than often it's because of the cultural experiences that emphasize left or right brain thinking. So we're not talking too much about vision for the class, but for this discussion. But we know that we have two eyeballs and each eyeball goes back to the back part of the brain called the occipital lobe. So one eyeball goes to both hemispheres. One eyeball goes to both hemispheres. So we have binocular vision. So you have one eye, but you can see a landscape. One of your visual fields may be missing if you close an eye, but essentially both eyes go back to the brain. So there's areas that cross. So on the outside of your eye, you have the temporal division where it goes straight to the brain. It's on the inside of the eyeball that it crosses and goes to the opposite side of the brain. That place that it crosses is called the optic chiasm. We talked about it before when we went over vision, but in this context here, we're speaking about a place where the eye pathways cross, the optic chiasm. You can go over that on the slide on your own. At this point, just want to make sure you understand. One brain, two hemispheres, but they must communicate somehow, and these are the places that communicate. So on the underside of the brain is the underside of the brain. You see the optic nerves. Here's the optic nerves, two eyeballs. On the outside, as we said, it goes to the same side of the brain. On the inside, it crosses. And that's that place in the middle where it crosses is called the optic chiasm. So this is again the underside. That's the olfactory bulbs for smelling. You look at that, and right here the optic nerves. Even though it looks like they're going straight, they do, but again they have to cross somewhere to make sure it gets to the other side of the brain. So with beyond vision, you have auditory connections. There are ears right here. So it pretty much goes to that same side of the brain. Although it says the auditory system is arranged differently, each ear sends information to both sides of the brain. And so the brain areas must compare input from both ears. And so it's not like one ear is only going to one side of the brain, but there is some crossing also. Each hemisphere does pay more attention to the ear on the opposite side. That's interesting. So again, vision and hearing can have different ways that it communicates to get to brain areas, and the corpus callosum is the crossing site that happens. So there are patients that are called split brain patients, where they can have surgically this corpus callosum cut, brain still intact, but the corpus callosum is cut. That means left and right are communicating. That can create some problems. So you already know that the left side of the brain controls the right side of the body. Right side of the brain controls the left side of the body. So if you're now going to cut that area right in the middle, no communication. And we'll see an example of that when we deal with language. Language is primarily left hemisphere. Primarily. And if you show somebody something in, say, the right hemisphere or the right visual field, it gets to the left, they can say what it is. If you show somebody what's in the left visual field, it goes to the right brain, it can't go across because it's cut, and it can't get the language area to say what it is. So split brain people or patients can have a problem if that corpus callosum is cut. So beyond the language issue, they may also have some disconnections with some behavioral phenomena. We won't get too extensive on that, but the point is that that's why we have some problems with split brain people. So why would you have split brain people? Well, they would be maybe having a problem like epilepsy. So epilepsy, we've talked about it before, is an abnormal firing of cells. A person could have a seizure. So rather than having those neurons being too activated all over the brain, a neurosurgeon may cut corpus callosum so it does not spread, but the side effect and the outcome is, again, split brain problems. And so let's just say it's a surgical option for people who have epilepsy, but it can also impact your intellect. And when you look at the slides, you'll see an example of, again, with the word in front, but a person with split brain may not be able to say actually what it is if it's going to the right hemisphere where there is no language. If it doesn't get to the left hemisphere to say what it is, you can't say, they can see it, think about it, but they can't say what it is. So moving forward, as we said, left hemisphere, primarily language abilities. Right hemisphere, we're saying helps out to see the bigger picture, holistic thinking. So think about that as you are dealing with your studies and as you learn and read. It's more better to have a global perspective on things. That is really using all of your brain versus one-track minded and only seeing one thing on a linear path. Left brain thinking. Our society we're living in, unfortunately, is like that. We don't want to be stuck in that manner. We want to be able to see it globally. So using both sides of the brain, emphasizing that right brain thinking is preferable. So there are some studies where actually people can inactivate parts of the brain. Inactivate, right? You can actually, rather than surgically doing it, you can actually give them some drugs, something called sodium amytal. People can, like doctors, can inject something into the bloodstream. It goes to a hemisphere, it shuts the hemisphere down, and then you see all the activity going on to another hemisphere. So scientifically, that can be investigated to see the emphasis on one hemisphere versus the other. So there's some people who have emotional disturbances, and sometimes it could be because the hemispheres aren't working properly. Meaning that some people really don't recognize if someone's sad or they're having a problem in their brain, they can't recognize those as real issues. So moving forward, the main thing about language I would like for you to know, don't worry too much about the primate data. You got parakeets, you got parrots that can, or birds that can kind of intonate sounds like humans. The main thing I want you to know about language as we move forward through the slides is left hemisphere function. So, two areas I want you to know about, one called Broca's area, one called Wernicke's area. Broca's area, Wernicke's area. So if you look at the brains, you couldn't really see, it's just one color for a real brain, but there's areas, Broca's area, Wernicke's area. Up here, Broca, Wernicke. And you notice Broca is primarily for speech production, getting the words out. Wernicke's area, even though it's a W-E-R, for the German word Wernicke. Wernicke is for speech comprehension. Now I want you to look now where those areas are. If you think about it. Frontal part of the brain, back here in the middle part of the brain. This is around the temporal area, this is around the frontal area. If you recall, the frontal lobe has motor functions, a motor cortex. So it makes sense for Broca's area, if that's disturbed, the lips don't move, tongue doesn't work, can't get the sound out. So think about people who have strokes. That's what's going on when they can't say something because that area may be disturbed. The middle cerebral artery is a place that innervates a lot of the brain areas, and if that area is occluded, it is blocked, and therefore not getting nourishment to the brain, it may not work right, so the speech is impacted. So that makes sense why speech and production in that area. As you move further back, you think about where the ear is. So the ear is close to here, going there. So if that part is disturbed and the cells aren't working right, the person can't comprehend what you're saying. They can say something, but they quite can't interpret what you're trying to discuss. So that's primarily emphasized in those two areas, Broca's area and Wernicke's area. So I would like you to know those. And even in terms of speech, there was a movie called King's Speech about a king there in England who basically had problems with stuttered, couldn't speak right, and went to a doctor to try to figure out what the problem was, and essentially he got frustrated. But he was in one of the sessions, and they were playing music. The doctor played music behind him giving his talk, so he had to read, let's say, some document. So he's reading the document, and he's trying to read through it, and he's getting frustrated, and he just puts the paper down and leaves. But the doctor then goes back and listens to the tape, and the person was speaking fluently. So it's almost like the music in the background distracted the person, and they didn't have to stutter. They were able to read comfortably, even though they didn't know they were doing that. So that person was called back to the office to say, hey, guess what? We have a new way of helping you to deal with your stuttering. So there are some diseases or disorders of language. One of them that's talked about in the book was Williams syndrome. It says characterized by intellectual disability, but a skillful use of language. It says there's a gene involved, chromosome 7, leads to decreased gray matter, especially in visual processing areas. So there is a reason why there are some people that maybe can't read too well or do have a problem with words, and it may be a brain issue. That's where dyslexia comes from. A problem with maybe processing images, crosses, and lines, and therefore they can't interpret properly. So again, in terms of this chapter, Broca's area and Wernicke's area are primarily in the left hemisphere. And as we talked about with strokes, again, if a person has a stroke, on the left side of their head, the right side of their body is impacted. They have a problem or a stroke on the right side of the brain, the left side of the body is impacted. So think of the stroke rate as a brain heart attack. You have a small, say, occlusion, that is a blockage. And if you ever heard the doctor talk about TIAs, TIA, that stands for transient ischemic attacks. Those small occlusions that don't allow the blood supply to get to the brain, and so over time, it looks like the person really has a problem. So you can detect a stroke very early. A brain aneurysm is really a full-blown bursting of a blood vessel, and that's not good. Hard to survive from that. So strokes come from, again, high blood pressure issues, dietary problems, eating wrong foods, clogging the arteries up, so nothing can get through. Therefore, as it gets occluded, the brain gets impacted, stroke. So for Broca's area, it's also known as non-fluent aphasia. Anytime you see the word aphasia, a word with A in front of it, it refers to a lack of, loss of. So aphasia is loss of language abilities. So for Broca's, not fluent. That's why I call it non-fluent aphasia. You can look at the slide to get more information on that. Wernicke's aphasia is looked at as fluent aphasia, because he can talk, but the loss of language deals with the issue of comprehending what's being said. Located near the auditory cortex, characterized by impaired language comprehension and ability to remember object names. So that part of the brain, again, fluent, but loss of ability to extract certain information. So there's a little chart for you on your slide to go ahead to compare the two, the differences. Please know that. We won't emphasize too much about language and music in the test. Don't worry about that. But with music, again, creativity, right hemisphere functioning. The issue of what you're listening to and learning. You have to, some people read music, some people don't. Reading music, left hemisphere, right hemisphere, improvisation. So those who have the ability to kind of take that to another level, like a Miles Davis, a John Coltrane, and people who have extemporaneously just felt the music and created a whole new way of how we view things. Look at the movie Drumline. Think about the brothers playing drums. I mean, you never read music, but they had a whole different way of connecting. So that music and language is very strong, but again, it does depend upon how a person's brain is receiving the information. And again, just as we conclude this chapter and the lecture, dyslexia really deals with a problem with the brain really seeing, let's say, lines or crosses. So the person maybe can't read. They may be seeing things upside down as they're looking at it. So the brain is doing that. So it's more common in boys, could be linked to some genes that are causing that problem. Doesn't mean that people with dyslexia cannot learn. They can. There are schools, like over Vermont, like Landmark. There are schools that are set aside for people with dyslexia, people afford the money to pay to go to that, versus the problem we have in our communities where kids and people are going through school, not being able to read, and it's never been tested as to what the problem was. So they can go and graduate from high school with dyslexia and never knew there was really a problem. That can be very detrimental to a person's educational experience. So again, you can look in the slides to see more about the nature of dyslexia. And then the last part of the chapter dealt with attention and consciousness. I'm not going to test you on that. However, there's a lot of good information pertaining to that, specifically when we talk about a term called inattentional blindness. There's an experiment called the invisible gorilla that discusses that. In class, I would show you that on video and have you kind of look at that and show you that you can be conscious of certain things and unconscious of certain stuff. But now in 2020, we're now doing these remote lectures, these remote access lectures. All you're hearing about is this coronavirus. So your attention is focused on that. Meanwhile, things could be happening that we're not paying attention to. What things could be happening on a grand scale? Hey, it could be some issues like $1 trillion relief for businesses, not people who are struggling like students with debt, but things are happening where they get your attention somewhere else, but something else is happening to you. So consciousness, when our consciousness is being manipulated, as we are being manipulated now with this whole dynamic of what's happening, everybody's living in fear, that is not a great state to be in. So this last part of the chapter, dealing with consciousness and attention, is really discussing that issue of what your brain really pays attention to. So we will not go into depth on that, but we will conclude by making sure you're aware of, again, the issue of how the brain, left and right, individually have functions, but collectively they are important to what manifests behavior. Okay, so that's chapter 13 on cognitive functions.